Okay, now let's see this question. This question came in GATE 2014 and it came for 2 marks. Okay, the question is, a pinant is a sequence of numbers a sequence of numbers, each number being 1 or 2. So an n pinant is a sequence of numbers with sum equal to n. So for example, this is a pinant, so where the numbers are either 1 or 2, so 1 1 2, so this is a sequence, and the summation of them is 2 1 2 plus 1 plus 1, which is 4. That's why it is called a 4 pinant. So they are saying that n pinant is a sequence of numbers with sum equal to n. So all the numbers sum, if that is 4, then this is a 4 pinant. Okay, now they're saying that they're basically giving examples. So the set of possible 1 pinants is this. So this is the only possible pennant, only possible 1 pennant. Okay, what are the possible 2 pennants? So possible 2 pennants, you can say 2 and 1 comma 1. Okay, this is the only way in which you can get pennants, and its summation, the summation of the numbers is 2. So okay, now they are also given the example of 3 pennants. So 3 pennants, you can understand it something like 1 1 1, this is one way, and the another way is 2 1 and then 1 2, 2 1 and then 1 2. Okay, so these are 3 ways. Now they have given the example. So in the same fashion, they have also said a reminder that note that 1 2 pennant is not same as 2 1. So we are counting 2 1 and 1 2 separately. They are not same, they are in fact equal. So they are basically saying that the ordering inside the pennant matters. So basically this is a ordered tuple sort of thing that you can understand. Okay, now they are saying that in the same fashion, if we continue, so this is basically, you can understand something like, let's say p n b denoting number of pennants, a number of n pennants. So this is basically p1, this is basically p2, number of pennants, number of 2 pennants, this is number of 3 pennants. So in that same fashion, they are asking you to find p10. So number of, what is the number of 10 pennants that they are asking? Okay, okay, so there are many ways in which you can understand this. So one of the ways is something like this. So let's say you are talking about n pennant, and n pennant is some tuple. So let's consider it like a box. So whatever numbers are there, let's say they are at some positions, and we'll analyze it like this. So if this is an n pennant, it means that the summation of all the numbers, so here also 1 or 2 can be there, here also 1 or 2 can be there, whatever numbers are there at each position, and it can be, I don't know what is the length, so whatever be the length, the thing is that the summation of all these numbers is n. That is exactly the definition of n pennant, right? So if we are talking about n pennant, then the last number, in fact any of the numbers can be 1 or 2, right? So but we will analyze like from the last number. So let's say this last number is 1, it can be 2 also, but let's say it is 1, that is the case 1. When it is 1, then what can you say about this thing, the rest of the thing? You can say that, okay, if this thing is 1, I know it means that this thing is basically a pennant n minus 1, it is basically a n minus 1 pennant. So my point is that you take all the n minus 1 pennants, attach 1 at the end, and then you will get a n pennant. I will show you an example. So see here, where in these 3 locations we are getting 1. So this is the place where we are getting 1, and this is the place we are getting 1 at the last position. So we are talking about only the last position. Now you see that what is this? This is basically, we have taken all the 2 pennants, 1 1 and then attached 1 at the end. We have taken 2 and attached 1 at the end. So whatever is the number of 2 pennants, if we simply attach 1 at the end, we will get 3 pennants, right? So we can write a recurrence formula sort of, Pn is equal to Pn minus 1 plus there is another case. So this is the number of ways, number of n minus 1 penants. So whatever is the number of n minus 1 penants, there is only one way we can have 1 and we will get all the n penants when 1 is there. When 2 is there at the end, see, when 2 is there at the end, then what is going to happen? This thing, this whole thing is basically going to be a n minus 2 penant, isn't it? So we take all the n minus 2 penants and then attach 2 at the end, and that many we are getting n penants from this case also. Okay, so you can understand that, okay, if it is P3, it is a 3 pennant, and then at the end we are having 2. So 3 minus 2 is basically 1. So whatever are the 1 pennants, we are simply going to attach 2 at the end and we will get that. In fact, there is only one pennant, right? So 3 minus 2 is 1. There is only one pennant. There is a single 1 pennant, and if we attach 2 at the end, we are getting the 3 pennant, right? So you understood that how we can get 3 pennants using this formula. So here we are going to get Pn minus 1 plus Pn minus 2. So these are the cases when the last number is 1. These are the cases when the last number is 2, and in that fashion you can understand that we have got in fact a formula. We have got a formula where Pn is equal to Pn minus 1 plus Pn minus 2. In fact, this is very famous. You can understand it like this is basically Fibonacci sequence also. However, the initial conditions might be different, but let's see what are the things. So let's see what is P1. What is P1? So P1 is number of 1 sequences, number of 1 pennants, which is basically 1. What is P2? P2 is number of 2 pennants, which is 2. These are the terminating conditions. And then after that, from P3 onwards, you can simply apply the formula. So they are saying that Pn is equal to Pn minus 1 plus Pn minus 2. So P3 is basically P2 plus P1. What is P2? 2. What is P1? 1. 2 plus 1 is equal to 3. And in fact, you can verify from here also that P3 is basically 3, right? In that same fashion, we have to continue and we can directly calculate in this fashion what is P4, what is P5, what is P6. In that fashion we can calculate, right? So P4 is basically going to be 3 plus 2, which is 5. Okay, P5 is going to be 5 plus 3, which is 8. P6 is going to be 8, 5, 13. P7, P8, P9, and the answer which we have to give is P10. And in that fashion we can compute. So 13 plus 8 is 21 plus 13 is 34. 34 plus 21, okay, it is going to be 55. 55 plus 34, which is going to be 89. So P10 is 89, and that is essentially they are wanting the answer. So the answer is 89. Okay, the answer is 89. However, I will give you another way in which you can compute the same answer. Okay, so let's say we are thinking it like this, that okay, whatever is the n pennant, so it will have some 1s, some 2s. Okay, that is only possible, right? Now the thing is that and they can be ordered in any ways. So 1, 2, 1, 1, 2, something like this. So a few 1s will be there, a few 2s will be there, and then they will be arranged in some order. So we can use combinatorics to find such whatever is the count. The only thing is that we have to divide it into some cases. So let's take case 1 where there are no 2s. So let's say there are only 1s. So no 2s. If there are no 2s, then there are only 1s. How many 1s will be there? It is a 10 pennant. So there will be 10 1s. So there will be essentially 10 1s. When 10 1s will be there, then how you can arrange them? So basically there are 10 1s. Let's say how we are going to arrange them. That arrangement is simply there is only one way, because all 1s are basically unique, similar. So in that fashion, you can simply understand it like there is only one way. You can understand it like 10 factorial by 10 factorial also, right? Because all the 10 are distinct. That will become more clear in other cases, but there is basically only one way in which you can arrange 10 1s, because all the 1s are similar. Okay, now let's take the example where there is a single 2. Now when there is a single 2, then what is going to happen, that okay, there will be 1 2, and then since it is a 10 pennant, then there will be 8 ones. Okay, so there will be 8 ones and there will be 1 2. So the combinatorics question here is, in how many ways you can arrange 8 ones and 1 2. It will be basically how much? 9 factorial divided by 8 factorial. Why? Because these 8 are alike. So the answer is 9. Okay. In a similar fashion, you have to take the case for 2 2s. Okay. Now 3 2s, 4 2s and 5 2s. You cannot have more than 5 2s because 5 2s will give you 10. So we have to stop at that, and we have to see all the number of ways, and then we will simply add them, and that will give us the answer. And this can be done very easily. See, there are 2 2s, so basically there will be 2 2s, so 4 is already there. Now it is a 6 pennant, so it will be basically 6 ones, right? So 6 ones are there, so basically these 6 are also alike and these 2 are also alike. So you can understand it like there are 8 elements. Out of them 6 are alike of one kind and 2 are alike of one kind. So you can understand it like 8 factorial divided by 2 factorial into 6 factorial, and this will come out to be 28. Okay. Now when there are 3 2's, then basically 2 2 2 6, and then there will be 4 ones. So in a similar fashion, these are 4 elements and 3 elements, 7 elements. So it will be 7 factorial divided by 4 factorial into 3 factorial, right? This will come out to be 35. Okay. Similarly, if there are 4 2's, then 8 is already done, so only 2 ones can be there, and overall there will be 6 elements. Out of them 4 are of one kind and 2 are of one kind, and this will come out to be 15. Okay. And then there is one way in which there will be 5 2's, and all the 5 2's are alike, so there is only one way. You can understand it like this also. So you can understand it like 5 factorial divided by 5 factorial. So there are 5 elements and each of them are alike. So there will be 5 factorial is equal to 1, and it is similar to the first case where all were ones. Here all are 2's. So there is one way here, 9 ways 28. So basically we are adding all these numbers. So our answer of P10 is basically 1 plus 9 plus 28 plus 35 plus 15 plus 1, right? So in that fashion we have to simply add all of them, and then we will get simply the summation is 89. So again we are getting the same answer, 89, but I told you just another way in which you can think about it. Okay, so the answer is 89.